Polynomial function. I was going to dig up that John Cleese dead parrot sketch. Right? Poly. It's polynomial function. Poly in this case, not a parrot, it means many nomial numbers, terms, many terms, right? So you previously learned about linear functions such as y equals 3x plus 12, y equals negative a half x plus 3, and y equals 2x. These are expressed in the form y equals ax plus b, where a and b are real numbers and a cannot be 0, meaning we must have an x term. These functions are linear because the highest exponent on x is 1. That is, the degree of the function is 1. You've also studied quadratic functions such as, or this. All these functions can be expressed in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot be 0, saying I must have an x squared term. That's what makes it quadratic, because the highest exponent on x is, and the degree of the function is. Linear and quadratics are examples of polynomial functions. Some examples of higher degree, we have cubics, which are of degree 3, quartics, which are of degree 4, quintics, which are of degree 5, and actually sometimes after degree 3 we just say it's a polynomial of degree 4. Polynomial, if we get up above 5, then we just say it's a polynomial of degree 6, polynomial of degree 9, like whatever it may happen to be. And then here are some examples in kind of a standard form. This has a negative x cubed. This is in a factored form, right, which becomes very important. A polynomial function is a function of the form y equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 and so on, all the way down to a1x plus a0 or a naught if you're British, where n is a whole number and the coefficients and constant term a sub n to a sub 0 are real numbers. Okay? The real numbers, like not the square root of negative 4, but any other number. The highest power of the variable x is called the degree of the polynomial function, right? So we just look for the highest exponent. That'll be the degree of the function. The coefficient of the term of highest degree is called the, it's up front, it's in the lead, it's the leading coefficient. Okay, it's called the leading coefficient. So if you're given one that's in a different order, you can rearrange it in terms of highest degree going down to lowest degree. The term with no variable is called the constant term. Okay, the constant term. For y equals this, the degree is n, the leading coefficient is a sub n, and the constant term is a sub 0. Okay, so we say sub, just say it's subscripted. Which is the following below are polynomial functions. So, okay, fill this in. Identify, is it a polynomial function? Say yes or no. If it is, you can fill in the rest. If it's not, you don't have to. Right? I mean, if it's not a polynomial function, I can't fill that in. Well, the tricky one is like the fourth one, right? The fourth one is kind of tricky. Give it a shot. See if you can get that constant term and that leading coefficient and that degree. So see if your first line agrees with my first line. So yes, it is. It's of degree 4. The leading coefficient is a negative 2, and the constant term is. Okay. 2 and 3. Why is 2 not a polynomial function? It's a square root of x, right? That's an x to the 1/2. The exponent on the x must be a whole number. Anything down to and including 0. And then why is 3 not a? Okay, it's 5 over x, so it's 5x to the negative 1. And again, it's not a whole number exponent. Okay, what's the degree of this guy? It's of degree 3. The leading term is, and the constant term is So I'm going to end up with minus 60x. I will not have a constant term. It will be 0. Right? Each of these guys is going to get multiplied by negative 4x. They're all going to have, this will be the x cubed. This is negative 8x cubed. It's cubic, and it's got negative 8 as a leading. This will be plus 60x. And there's no constant term, so the constant term is 0. Okay? Make sense? Tricky, huh? Where do you see the test? In this course, for all polynomial functions, all the series, just do it step at a time. You know the drill. There are 6 things. That's all there is. Do not fake yourself out. Just follow the steps. List them in words. Just describe to yourself, this is what's going on. Make sure if you're given a diagram that you know you're going from this one to this one and not the other way around. Right? So make sure. Circle it, highlight it, say this is what I'm starting with, this is what I'm ending with. Circle it, draw an arrow to say I'm going from here to here. Right? Because we don't always go top to bottom, left to right. Sometimes we go right to left, bottom to top. Make sure you know which one is which. Make sure you can work with domains. Hey, if the domain was this and now it's this, then this is what happened. Okay? Read the question, read the question, read the question. Okay? Very important. It'll say transformation is done by only 2 stretches. All right, then I can't do translations. Or a stretch followed by a translation. All right, there's no reflections. Right? Make sure, there's other ways to do and get the results, but there's one way to do it correctly, and that requires you to read the question. Understand. Oh, okay, I can only do, it's just anything we did in the booklet, right? I could do 2 stretches and a translation, 1 translation. In this course, for all polynomial functions, all the coefficients will be integers. These types of polynomial functions are called, anybody guess? They're called integral, right? Meaning all the coefficients are integers. We will not have a root 2x squared, right? It'll be like a 2x squared. We will not have 1/2 x squared. It'll be a 2x squared. Review of x and y intercepts of linear and quadratic functions. State the y-intercept. So the y-intercept is a number. Do not write y equals -6. Y equals -6 is a horizontal line passing through -6 on all its y values, right? So we say state the y-intercept, give me a number. You write y equals -6, you give me the equation of a horizontal line. Algebraically determine the x-intercept. How do we get the x-intercept? We set y to 0. Here, it's okay to write x equals 3, right? Because in the context of the question, if I said, the x-intercept is blank, and determined, you'd work it out, then you would just write a 3 in there, right? Do not write x equals 3. When we do this, you can write x equals 3. We understand that that's what's going on. Use the x and y intercepts to sketch the graph. A sketch must be, you can't put x equals 3 over here. You can't go put there and say -6, right? You can't do that. You put 3 there, put -6 there. They don't have to be scaled the same. You're just drawing a sketch. Draw a line. Put an arrow on each end. It's a straight line. It must go on forever both ways. And there, we got an x-intercept of 3, a y-intercept of -6. We've drawn a line. For the function, y equals x squared minus 2x minus 8. What's the y-intercept? -8. Right? So, you can almost generalize. I'm going to make a statement. You fill it in. For every polynomial function, the y-intercept is the constant term. Why? Because you make all the x's 0, so every other term zeroes out. Right? It could be degree 17. The 17 zeroed out. So did the 16. All we're left with is the constant term. Algebraically determine the x-intercepts. How do we do that? Okay, the x-intercepts occur when y is equal to 0. Tomorrow when you're doing the test, read the question, try and figure stuff out, draw a diagram if you're having problems, try and picture what's going on. Think about it. If the answer doesn't come to you reasonably soon, go on and do something else. Come back to it later if you have time. There's no point wasting 20 minutes trying to get 1 mark. Okay? What's your job on a test? If you have a job, what's your job on a test? Get the highest mark you can. Does that mean you do every question in order until you have come up with an answer, leaving 4 questions at the end blank? No. Right? You have to get the highest mark you can. I'll give you my method quickly. 3 passes. I go through a test in 3 passes. Number 1, really easy question. I know how to do. It's going to take me like 30 seconds. I do it right then. Number 2, question that I know I can do, but this is going to take me a few minutes because I'm actually going to have to use the quadratic formula and work out an exact value for x-intercept. I could do it. I'm not doing it now. It's going to take me more than 30 seconds or a minute. Number 3 type of question. Wow, I wish I had done the homework. I've never seen this before in my life. I have no idea what this is asking. I don't recognize this. Did we do this? I was away that day. Okay, that's number 3 type of question. So you've done all the number 1 questions. You now go back and you do the number 2, right? Okay, I got to use quadratic formula. Great, let's fill it in. It's just working it out. It's slogging through some algebra, right? Once you've done all the number 1 questions, the number 2 questions, now you get back to the number 3 question. And it's all of a sudden you're looking at it going, right. That question I did on the back of the last page, that's just what I have to do for this now. Now I know what I'm doing and I can do it. Or it's still one of those questions that I was away that day and, so I have no idea what this is asking. Then what you do is you do this. You go back, you double check the number 1 and number 2s because that's where most of your marks are going to come from. And spending 10 minutes on the number 3 question that you have no idea what it's asking is not likely to yield a lot of marks. So go back, check over everything else, then come back to it and you look at it, so okay, I got 20 minutes left. I can pound on this for 20 minutes knowing that everything else is done as well as I can do it. And if I waste 20 minutes and get no marks, it's okay because I've gotten the highest mark I can to this point. That's how I do it. Feel free to do anything that you like to do. Oh, I would advise this. We're going to give you a scan sheet for the multiple choice. It's not going to be all that big. Make some sort of a symbol, a legend for yourself, right? That is, if I circle number 1 on the multiple choice, you're allowed to circle the number 1. It's okay, it won't read it, right? Just make sure you bubble in the bubbles. And you say to yourself, my deal is, if I circle it, I knew this 100%. I am willing to bet $20 this is the correct answer, and I will be very disappointed if this is wrong. Maybe a little square around it means I'm pretty sure, but not betting $20 sure. And maybe a little star around it means I just took a random guess, and if I get this right, it means I don't know how to do this, and I need to look back and see why it was what I thought it was. Okay? And little question mark next to it. Don't leave any of them blank. Right? And then do the same thing for numeric response. So put down, I knew this. I knew this cold. This is it. I'll bet 20 bucks. Right? And then at the end you say, I owe you 100 bucks because seriously I got like 5 of these wrong. I thought I knew. Right? But you don't have to tell anybody that. But that's feedback to you when you get it back. Right? You have something to look at, not, oh, I just randomly guessed that. Just, how'd you get 7? I don't know. What did you do? Like, if you can't answer me, how did you get that answer? I'm not even talking to you about the question, right? What we got to talk about? You don't know what you did. So go out and figure out what you're supposed to do, then come back, we'll talk about it. There's no point in discussing this if you can't tell me, here's what I went through. So show your work on the multiple choice as best you can. Squeeze it in, right? Like that's what I did. I just write everything out. Number 1, it's a vertical stretch by a factor of 3 about the. Number 2, it's a horizontal stretch by a factor of 1/3. Number it's this, right? It's like that. So if you were looking at it and say, all right, see that? That should be a 3rd, not 3. Oh my God. Okay, good, right? I'm good. I know what I did wrong. It won't happen again. Okay, and on the written response, you have to show everything anyways. All right, anyways, algebraically determine, there's the x-intercepts. Thank God it factors. X squared plus 2 minus 4 is minus 2 minus 8. If you're going to factor it, make sure that it actually is the correct factorization. Check it. Okay? You go from here to here, this is wrong. Guess what? This is all wrong. Guess what? Anything over here? Wrong. Okay? So check that. Does it ask us to graph them? Oh, use the x and y intercepts to sketch the graph. So, again, I'm not looking for exact, but if you put -2 here, don't put 4 here, right? I'm going to ding you if you do something like that, but, and it doesn't have to be perfect. I'm not going to measure it and say, that wasn't twice the distance. You're going to lose marks, right? So, yeah, that's good. Okay, we know the y-intercept, right, was -8. We can go a little better on this because the vertex has to be halfway. These guys are 6 units apart. Halfway is 3. I got an axis of symmetry running through 1. If I throw 1 in there, I get 1 minus 2 is -1. I get -9. So I know that 1, -9 is the vertex. I know it goes through here. And I know it goes through here. And I know it goes through here. And I get another point here if I really want it, which is the point 2, -8. Right? It's 1 unit away. Right? And it opens up because A is 1, and it's vertically stretched by a fact. It's not vertically stretched, so if I go over 1, I go up 1. Symmetry, blah, blah, blah. Right? Okay, nice sketch. Okay, labeled nicely. Give me a nicely labeled sketch. That's all I ask for. Right? The functions y equals 2x minus 6, y equals x squared minus are expressed in simplified form. When it's in simplified form, the y-intercept is obvious. State the y-intercept. What's the y-intercept? Okay. We're allowed to have y equals. I wish we were consistent. I feel bad that we're not. Here, y-intercept is y equals 1. The function y equals x minus 4 times x plus 2 is expressed in factored form. When it's in factored form, the x-intercepts are obvious, or at least easily calculable. State the x-intercepts of each of the following. Okay, what's x? And what's x? Okay, and how do you do that? You set x minus 7 equal to 0, and you solve for x. Right? What do we want? We want y to be 0. How do we get y as 0? If one of these is 0, the whole thing's going to be 0. And so we do 2x plus 3 is equal to 0, 2x is negative 3, and x is negative 3/2. Easy way, take this, change the sign, stick it over this. Because that's all that's going to happen, right? This is going to move over to the other side, changing the sign, and then you can divide by whatever's in front of the x. Okay, what's this guy? Negative 3, right? It's the value that's going to make that 0. Hey, there's 3 of them here. What are they? X equals 2, x equals 5/3, x equals. Okay. Again, if you need to do any of them in detail, 3x minus 5 is equal to 0, 3x is equal to 5, x is 5/3. Okay. Whatever works for you, you do what you need to do, right? And the last one, x is this one, 0. X is, you can't do that. It says x squared is negative 1. You can't make x squared negative 1. Right? You got x squared plus 1 is equal to 0, which says that x squared is negative 1, and there's no solution to that. Okay, and this one, negative 7/4. Right? Oh. On to the next page. It's an investigation, so I should just turn you loose to investigate, but I won't do that. We'll go through a bunch of this together. So it's going to be one of these where we're going to go through a number of them together, and I'm going to leave a number of them for you to do on your own. In this investigation, you'll examine the effects of the degree and the sign of the leading coefficient have on the graph of a polynomial function. So we're going to do a bunch of these and come up with a hypothesis, right? We're going to say, oh, if this, then this is what it's going to look like, right? Here are the possible characteristics, not necessarily the exact characteristics of that one, but if I give you an equation and say, without using a calculator, tell me about this, then you can tell me stuff, right? That's what we're looking for here. Following equations of polynomial functions are represented in simplified form. Then we need the factored form. From the factored form, we'll get the x-intercept. From the simplified form, we'll get the y-intercept. We will determine whether there are relative minimum or maximum points. You know what that looks like with a quadratic, right? Only those are absolute minimums and maximums, not relative. But in a cubic, there are relative, right? Like relative to the point. By relative, we mean in this area, this is the lowest point. Okay? In this area, this is the lowest point. Relevance, there are none. It's a line. Lines are straight. They don't have mapping. And domain and range. Okay, so let's do the next one. Oh, let's do this first. What's the sign of the leading coefficient? Plus, minus, plus. I think we can just run down and fill that one in, right? Minus, 2, no, plus. What's the sign? Show me. Want to put down a number. I cannot write an infinity sign without throwing a square bracket next to it for some reason. Very last thing, if you do have time at the end, go back through your test. If you have any infinities and you've written a square bracket next to them, I apologize for modeling that for you. Take out your eraser, please. Erase them and put a parenthesis. Also, do this in pencil, bring an eraser. Oh, I have the world's greatest pencil sharpener over there. I'll show you it later. It really is. You can ask the other 2 classes I saw it. It's from Japan. The box is just all Japanese. Instructions are in Japanese. Right? Polynomial in factored form. So the factored form of this is what? Okay. Plus 4. See? Good. See, I always do that when it's a minus because it turns very easily into a plus. Plus. Who knew? X-intercept. -4. Y-intercept. -12. What kind of a thing is it? It's degree 1. It's a line. Lines can't have turning points. They don't turn, so they can't have a relative min or max. Domain and range, same. Lazy. Domain equals the center one x, which is x belongs to reals. So just on the test, be consistent. If we give it to you in interval notation, give it back to us in interval notation. If we give it to you in whatever that's called, set notation, give it back to us in set notation. And let's draw that. So we got -4, we got -12. Actually, probably -4, -12. Arrows on both ends, right? The sketch needs to be, semi-accurate, right? I can't say -4 and have it sitting on the positive side, right? But other than that, blah, blah, blah. X squared. This is a parabola that opens which way? Up. So it has a minimum. And the minimum point is... how do we do that? So you could graph this, right? Or you could say the x-intercepts are -2 and 4, so then it's at 1. That's what we did, isn't it? It's at 1, 9. 1, -9. Right? 1, -9? Okay. Remember we did that? It was on the other page. Oh, no, we did that one. So I need 1 negative. We already sketched that. Just say see other page. We already sketched this. Why are you making us do this over? 1, -9. So there's -8. This is 1, -9. This is 4. This is -2. Label where you can, right? Yep.
You can also.
Isn't that harder? I don't know. See, I would do that if we didn't already have it, but we already have it, right? Yeah, you could complete the square root, and bonus, you do it on your calculator and just go second calc minimum, okay? Because some of these, when we ask the relative min or max, we're going to do it on our calculator. We're just going to round it to the nearest 100, okay? Because we don't want to go through figuring out exact values. It's not the point of this. Okay, -2x squared plus 7x plus 3. There's the factored form. It's got a negative leading coefficient. What are these? X-intercepts? What are they? 1/2 and 3. What's the y-intercept? -3. What's the coordinate? Okay, wait. Which way does it open?
Down.
It opens down. So for a minimum, what are we going to put? There is none. And for a maximum, what are we going to put? Let's get around this. So we'll do this on our calculator. I don't have a calculator. Okay, so please just graph it on your calculator. Give the coordinates rounded to the nearest 100th. Okay, so we're just going to go to y equals. Which one are we going to graph? This one or this one? Doesn't matter. First one's probably easier, right? Okay, -2 x squared. Just watch because when you do cubed, it's going to stay up there, and then the next thing you look up, and it's like, wow, there's all my expression up top, and it's not supposed to be. So, but in squared, it does actually come down where it's supposed to be. Plus 7x minus 3. See, I know. It's not a minus sign now. I got a. Okay, I'm just going to hit graph in the standard window and say, can I see enough stuff? Is this good? Yeah, okay, that's cool, right? So, as a maximum, where is it? Second calc maximum. Wants a left bound, so you must be to the left, which is there. That's to the left. Then a right bound. I like this one, right? Puts in a little line. You just get a little thing up there. And it's just showing you and saying, I'm going to look in between here and here. And then, but I'm going to really look here, because you give it a guess. And it comes back with what? 1.75, 3.13. 1.75, 3.13. Okay, so for any of these guys, we're just looking right now just to the nearest hundredth. Right, we just want an idea. Domain, what's the domain of every polynomial function there is? X belongs to the real, right? When do you change domains, right? Well, if there's an expression in the denominator, which you can't have in a polynomial, then you'd have a non-permissible value, but we don't have that. If there's something under a radical sign, if an x is under a radical sign, it's not a polynomial. So it's just x belongs to the real. Oh, they never did a range here. What's the range of this? Y is greater than or equal to -9. This is x belongs to the reals. This is, the range is y such that y, what? Less than or equal to 3.13. Okay, so I need the point 1.75, 3.13. I need an intercept at 1/2 and 3. And I need a y-intercept at -3. -3, 3, 1. There, everything's really nicely labeled. It's reasonably accurate sketch. Actually, on the sketches in the key, they don't even label anything, so you don't necessarily need to label it, but if you want to, go ahead. Okay, y equals 2x cubed. Does anybody know what that looks like off the bat? It's like a what? It's a snake. What? Okay, so probably we have to graph. Okay, but what are the x-intercepts? -3, -1, 5/2. What's the y-intercept? -15, right? So from these two forms of the equations, and even really, to get the y-intercept, just put a 0 in there. Just go, okay, it's 3 times 1 times -5, right? 0, so you get -15. Okay, it's not hard to get the y-intercept from this. It's just a little more work. And relative max or min? Yeah, maybe. I don't know. Let's graph it. Okay, I'm going to y equals. I'm going to clear that out. So I have 2x cubed. This is where I got to move back down, right? Because it'll stay up there, so I don't want to do that. So just say, only to move back down, I think you actually just go to the right. To the right. Okay, 2x cubed plus 3x squared plus 3x squared. Okay, I don't have to worry, it moves back down. Minus 14x minus 15. And hit graph, just use the standard window, and we'll see if we have to adjust. Okay, cool. So I might want to adjust that a little because I know the y-intercept is -15. So I'm going to go in here and change my y min to like -20 so that I can actually see the y-intercept. So we're interested in, actually I gotta go a little bit lower because that's a relative minimum and I need to be able to find its coordinates. So it's a process of iterative refinement. And actually I can cut in a bit, right? Like say -5 to 5. And then let's go down to say -30 and let's see what that looks like. Okay, better. Nice. That works. Okay. So for the sketch, I'm just looking for something that looks like that. You don't even have to label it now, right? It could get too ugly if we label it. But I've got x-intercepts, 2 of them to the left of the axis and 1 to the right. Sure. It disappeared. I hate when that does that. Okay, good enough, right? It's got a maximum there, it's got a minimum there. There's 2 of these to the left, 1 to the right. It has a y-intercept. That's all I'm interested in, right? Okay, general shape. Now, what's in this none column? What is this thing? Maximum. Minimum. Does it have a minimum? Okay, it's relative minimum, right? So there, relative to the rest of the points around it, this is the minimum. Okay, let's go find it. Second calc. Minimum. Okay. To the left, enter. To the right, enter. A notification on the watch, enter. 1 point, is that an 8? 1.19 and negative 24.
It's a 0.
Is that a 0? Okay. I can't. 1.11 and negative 24.11. Okay, and this is minimum. 1.11, negative 24.11. Maximus. Not really, it's a maximum. I have to say that. I did the selfie with Maximus, but I didn't post it. I don't use Instagram, so I just tweeted it. Enter. Enter, and a guess. Negative 2.11, 9.11. Negative 2.11, 9.11. It's the domain of every polynomial function. What's the range? Look at the arrows, right? Going down forever, going up forever. The range is all real numbers. Okay, you do the last one. Round to the nearest 100. I shall pause. So I'm going to assume I copied well. So what we're aiming at here is that we can look at a linear, and we can look at the sign of the leading coefficient, and we can start to notice something about it. We can look at a quadratic, and we can look at the sign of which we already know. We know that from last. Now we can look at cubics, and again, hey, the sign of the leading coefficient tells me something. The x-intercepts, like all of that tells me something. If I just say, draw me one with these 3 x-intercepts and this y-intercept, maybe you can draw it the other way, right? Maybe not with this y-intercept. That would kind of nail it in. So now we want to start looking at, what about degree 4? What about degree 5? Now notice we've given you these guys. Okay, so I give you like 5 minutes to go through and fill in the rest of this table. Okay, so all you really got to do is sign of leading coefficient, x-intercepts you get from the factored form, y-intercept you get from that form, and then draw a sketch, graph it on your calculator, draw it in there, and just sort of start looking at, right, actually before you sketch it on the calculator, just try and think, what might this look like? Right, if I had to draw something here. Okay, so now I want you to start thinking about, okay, not just blindly copying, but start thinking about, well, what am I seeing here and why, and what's it got to do with anything else? And I will pause this. All right, so there's the answers to those, right? And it's online, so if you're not quite there yet, you can certainly go online and look that up. Not tonight, of course, because tonight you'll be studying for tomorrow's test. Oh, one more name I know. So tonight you'll be studying for tomorrow's test. And then Wednesday night you can worry about getting caught up on polynomials. Okay, so let's move on. All right, so the whole deal in doing this, we did degree 2, we did degree 4, we did degree 4, we did degree 5. There's a connection between the degree of the polynomial and the shape of the graph. And actually, it's the possible shape of the graph, right? There's also a connection between the sign of the leading coefficient and the end behavior of the graph, right? Like what happens as we go to the right? Are we going up into quadrant 1? Are we going down into quadrant 4? What happens on the left-hand side of the graph? Are we going up into quadrant 2? Are we coming down from the bottom? Are we coming from low in quadrant 3? You can tell all of that from the equation. You don't need a graphing calculator to do that, right? You need to be able to know the characteristics. Use your findings above to sketch a possible graph. So I will let you do that on your own. I give you permission to do this on your own, right? And then you can check it with the calculator. Okay, but keep in mind some stuff, right? Which is, we were looking at degree 3s. It's going to back up to some degree 3. They look like this, right? But y equals x cubed looks like this. And y equals negative x cubed looks like this. So the negative is telling me end behavior, right? And as you start looking at it, you can sort of say, hey, end behavior depends on degree. Oh, wait, if the degree is even, it does this. If the degree is odd, it does that. And when you look at maxes and mins, right, or call these turning points. This is a turning point, right? The graph is turning. They say degree 2, how many turning points are there? Degree 2, quadratic. There must be exactly one turning point. You may not have zero turning point, doesn't turn. You may not have 2 turning points, lest g become degree 3, right? And then turn around and start going back the other way. Okay? Now, that's a possible number of turning points. This could have no turning points, it doesn't turn. It could have 1, it could have 2. How many x-intercepts can it have? Could have 3, could have 1, could have 2, can't have 0. Can have 0, can't have 0, can't have more than 1, must have exactly 1, right? So there's characteristics for you. And that's what we're going to start to look at is, see this, 1, 2, 3, 4, 5 x-intercept. 1, 2, 3, 4 turning points. Real, range is all real numbers, right? Comes from quadrant 2, goes to quadrant 4. Okay? In 30-2, we'd say the end behavior is Q2 to Q4 as I go from left to right. In 30-1, I'm not sure what we say yet, but we'll figure it out. There's some special language for it. Describe the relationship between the degree of the polynomial function and the shape. So I'm going to let you do that. So the shape would be this turning points, x-intercepts, right? All of that good stuff. Okay? So you start to think about turning points. So the degree, number of, in a sense, you can think of it as the number of sides, right? Like going up is a side, coming back down is a side, going up is a side. So cubic, 1 side, 2 side, 3 sides. Quadratic, 1 side, 2 sides. Linear, 1 side. Quartic, 1 side, 2 sides, 3 side, 4 sides. You don't need 4 sides, you could have 2 sides in a quartic, right? So it's what you can have and it's what you may have. Right? And then there's some where you must have. A linear must have the following. I'll let you complete this table, right? You can do it from the stuff you already have and you can just grab some stuff. Okay? So this is how we describe the end behavior. It extends up in quadrant 2 and blank in quadrant. Okay, so here we go. It's even degree and the leading coefficient is positive. It extends up in quadrant 2 and does what? It's also up in quadrant 1, right? And it could do this. So up in quadrant 1. Okay, and then you'll figure out the rest, right? Look at the table, look at even, look at degree 2, look at degree 4, look at degree 6. What happens when the leading coefficient is positive? What happens when the leading coefficient is negative? Look at degree 1, look at degree 3, look at degree 5. What happens when it's positive? What happens when it's negative? It will always happen. Okay? There are no exceptions. Graph of polynomial functions. State the degree of its function. So degree. Now, easiest way is to say, well, okay, 1, 2, 3, 4, 5, 6. So it is a minimum of what degree? The minimum of degree 6. Does it have a positive leading or a negative leading coefficient? It's a negative leading coefficient. Okay, maybe we should write negative. Okay, so you're going to know all of this, so you can look at an equation and give me the characteristics, right? Well, this could have 6 x-intercepts. It might not, but it could have, right? It will have down in quadrant 4 and down in quadrant 3 and down in quadrant 4, right? It will have if it's of an even degree with a negative coefficient. All right, algebraically determine. So we'll do these few hopefully before time runs out. Whoops. The y-intercept of each of the following. Algebraically determine the y-intercept. Well, okay, simplified form. What's the y-intercept? 13. Yeah, okay, so algebraically determine means show work. So tomorrow, algebraically determine means you show work using algebra. So that's an algebraic determine, right? It means I'm going to find the y-intercept by setting x to 0 and end up with y. If I just write down y equals 13, you didn't determine it. Determine means show work. You don't have to show work on the first page, which is machine score, right? It's multiple choice numeric response. No work to show. Okay. However, show your work. Like whatever work you do, please put it on there. That's for you when you get it back to look at. So the machine scored sheet, you'll get back to look at, I will keep. You can see it any time, wise time, before class, or whatever, right? Just let me know. The written response sheet, which is the, that will be given back to you to keep, okay? So the other one, you will see it at some point when all the 3-1s are done, you'll have access to it at any point.
So writing all over the booklet won't affect the multiple choice portion that's being written by the machine?
No. So you're gonna get a separate answer sheet, right?
Oh,
Okay, it's gonna have like 15 spaces, you'll fill in your name, you'll bubble in all these bubbles, and then it'll have 1, 2, 3, 4, 5, 6, and whatever, spaces for numeric. So that's a separate sheet. You can use the back of it as scrap paper, it's fine. Okay? And all that'll happen is I'll keep that, you'll get a report sheet that'll come out with it. I'll staple that on, you can look at it. We're also gonna categorize the questions as to the outcomes. You don't have to worry about that in a sense, but it's sort of like, I suck at specific outcome 5, which is this, right? So you'll know, right? Because it'll say specific outcome 1, you got 1 out of 1, 100%. Specific outcome 5, you got 1 out of 4, you got 25%. That's just pointing out, whatever specific outcome 5 is, I need to work on it, right? It's like I'm weak on, that's reflection. Okay. From the factored form, what do we do to get the y-intercept? We put in a 0 for x. So determine, remember, means show work. Okay, and then we just multiply that out. I got 1, 2, 3, 4 negatives makes a positive. Okay, so we got 240. Okay, so it'll be positive 240. Okay, so determine, second sheet, show work. Do something, show why it is. All right, so determining y-intercept, you set x to 0. Wow, that's the right thing. Okay. From which form of a polynomial is it easier to determine the y-intercept? So simplified or factored? Simplified, right? Because you can just read it out. And if a factor of a polynomial function is ax plus b, then what's the x-intercept? Negative b over a. Okay, here's how you do it. You say ax plus b. If that's an x-intercept, then the y value is 0. That must be equal to 0. So then ax must be negative b, and x is negative b over a. At each x-intercept, the corresponding y value is 0. We just mentioned that, right? In other words, the value of the polynomial function at each x-intercept is 0, right? If you evaluate it, you'll get a 0, right? A 0 means the y is 0. It means that it's an x-intercept. Why does this keep going up? Venice is traveling in Italy. It's like, use location services. I'm not that close. Since the value of the polynomial function is 0 at each x-intercept, the x-intercepts of the graph are also called the zeros of the function. Okay? So they're x-intercepts on the graph, they're zeros of the function, and they're roots of the equation. We'll get there in a minute. But for polynomial function p of x, if p of a is equal to 0, then a is a 0 of p of x, right? In other words, it's a value that makes the polynomial equal to 0. And then, okay, you do this. And you do that, and you do that. Oh, wait. the you do as I was supposed to do. But let's do the sign of the leading coefficient, right? That's a plus. This will be a minus. Then we got a plus. We got a plus. And we got a minus. Okay, watch out for this, right? Okay, 1 minus that. Okay.
It's when it bounces. I think this bounces off the sides. I don't think it bounces off that.
So that's going to be, so you just say I'm going to get a 3x, that'd be a negative 3x squared, negative 6x cubed, negative 6x to the fourth. I will have a negative leading term. And then this guy here, plus, it's all pluses. Okay, and then you can do that. All right, but not till like tomorrow night, right?